Okay, so in this video, we're actually going to work with double angle identities, and so we went ahead and did some identity work in section 14.3, and we did a lot of work with that. So we're going to work with double angle identities, and we'll do some half angle identities and work with that a little bit. But this is just manipulating formulas like we did in section new. With new identities. So you'll notice here that we have, so for example, in section 14.3, this would be sine of theta over cosine of theta. And you say, oh, okay, well that's the same as tangent, right? Well, now we got the same idea here, but now we have more things that we can work with and substitute. So I know my formulas, and so I know that sine of 2 theta is the same as 2 sine of theta times cosine of theta. So I'm going to go ahead and take this and substitute it in, because I see that if I know my formulas, the cosines are going to eventually cancel out. So I'm going to go ahead and plug that in, and I get 2 sine of theta times cosine of theta, all divided by cosine of theta. Okay, well I see that I got cosines are the same, so this guy is going to reduce to 2 sine of theta. And so if I was to graph the initial problem or graph the simplification of it, I would get the same thing. So it's a sine graph with an amplitude of 2. And so that's the process that we're going through, but instead of simplifying our basic trigonometric identities, we're using our double angle identities. Our next example, I have a couple different things here. I want to simplify this, and I have cosine of 2 theta. Okay, well I have a couple different things that I can put in for cosine of 2 theta. So I'm going to write my examples or my formulas over to the right, and then I'm going to go ahead and, because there's 3 that I can choose from, and so that can be a little bit, I don't want to say confusing, but there's a little bit of trial and error. So I know that the few that I have are the following. So I went ahead and I wrote them all down. Hopefully you looked at your notes to go back and find them. And this is what creates a little bit more of a challenging problem, is the fact that we got a couple different things that we can put in here. We've got a couple different things that we can put in here. So not only do I have my double angle identities, but I also have my Pythagorean ones. And I know that sine squared theta plus cosine squared theta is equal to 1. So maybe I can replace this, or maybe I can see that, hey, I got a sine squared here, and I got a negative 2 sine squared here. So which one do I use? I can use any one that I want. Well, I see that if I go ahead and substitute this one in for my cosine double angle, it's at the least going to match the same term I have on the right-hand side of the addition symbol. And I notice here, once I do that, I have 2 terms that are exactly the same. These are like terms. It's the same as negative 2y squared plus 2y squared. And so it's the same idea, and with this extra layer of all these different formulas. So I know that these 2 guys are going to cross out, and I'm left with my solution of 1. So even though I could technically have used my Pythagorean identity, I didn't need it. I had enough stuff right here to be able to work with it. And that's what becomes a challenge, is you might have to try a couple different things to see what works. But what I focus on is I looked for the one cosine double angle formula that matched this guy. And that allowed me to work with what I had. And technically, I could have used any one of them, and it would have brought me to the same conclusion, that 1, this is the same as 1. There might have been more work with the other 2, but I would still get the same exact answer.